Okay, good morning. It's September 7, 2023. My lesson for this morning will be AC machines, and this will now be lesson number 3. So for this morning, long video format discussion, alternating current machines, lesson number 3. Okay, let's proceed. For lesson number 3, the topic is regarding the rating and voltages of transformers. There are only two important ratings of a transformer, the so-called apparent power and voltage of a transformer. Because by knowing these two parameters, we could determine what will be the application of a transformer, whether it will be a power transformer or the so-called distribution transformer. Okay, let's proceed. For the power rating, since there are only two types of transformer with regards to application, that is power and distribution. Okay, with respect to the so-called power rating, the power rating is actually in terms of kVA or MVA. The one we computed under alternating current circuits, the product of voltage and current is actually the apparent power rating of transformers. With the, what you call this precedence letter here, K and M. K refers to kilo and M here refers to mega, meaning a million volt ampere. So MVA is actually a million volt ampere and kVA is actually 1,000 volt ampere. Okay. For a transformer to be considered a power transformer, the apparent power rating, okay, in terms of kVA, this should be 500 kVA and up. So if you see a transformer in which the power rating is 500 or 600 or it's greater than 500 kVA, it is to be considered a power transformer. An example of a power transformer would be the transformers, okay, for substations. The figure will be something like this, okay. The substation got a foundation cement on the ground, and at top of it are actually the big power transformers. These transformers are actually connected, okay, coming from the transmission lines. To step down the voltage coming from the transmission line, okay, so it should be a high voltage because for power transformers, the highest voltage for a power transformer is actually 154,000 volts. Okay, so maybe the voltage coming from the transmission line is 154,000 volts. Okay, and the transformer that should be connected to the transmission line coming from the power plant is actually a power transformer. That is, the rating should be a 500 kVA and up. Okay, because from the power rating alone, we could determine how many households could be what you call this power up by this transformer. So it's a must for us to know the apparent power rating, so we know if the transformer could deliver the needed power to households. Okay, that's for power transformer. So any transformer with a rating 500 kVA and up is considered to be a power transformer. And an example of a power transformer is actually this one here. This is just one figure, it's a front view. So this is actually the machine foundation. It's made of concrete. and on top of it is actually the power transformer. Actually, the configuration of the power transformer, it's not a cylindrical. Because if it's cylindrical, it is just a distribution transformer. It's very small. So actually, the big rectangular in cases of metals on substations are actually power transformers. Okay. Next one. For a transformer to be considered a distribution transformer, the power ratings will be, the apparent power ratings in terms of kVA will be this. The smallest one will be 3 kVA. Next one is 5. Next one is 7.5. Next one is 10. Next one is 15 kVA. Next one is 20, 25. These are standard apparent power rating of distribution transformer. 37.5, 75, 100, 250, and the highest is actually 333 kVA. So if you got a small business and you want an exclusive power to your business, actually you could order a distribution transformer from the utility company. Okay, you'll pay for it, right? So right beside the post near your company maybe, okay, this is the post. If you ask for a 15 kVA transformer for your company, they will give you a 15 kVA. So actually, if you are on the street, you can see the transformer hanging, and you can see the power rating there, 15 kVA and 440 volts. An example, just as an example. So for distribution transformers, if you are outside, try to look for the power rating on the markings on the side, because you can see it. If it's 15 kVA, it's 15 kVA. So if you know that the power rating is 15 kVA, supposed to be it is a distribution transformer. Meaning it's a transformer that is connected directly to what I call these clients. But for 15 kVA exclusively for one client, okay, he might have requested that distribution transformer to be installed near his business. So the needed power for his motors inside the business maybe will be supplied by this 15 kVA. Because without any transformer, if you got so many motor loads, okay, the operation of the motor loads will not be good enough, because there should be a reservoir of power, okay, to supply those motor loads. And the reservoir of power is actually the distribution transformer. It is just like in the water system, okay? If you got a big company and you need water, of course you should have a water tank. And the equivalent of the water tank for electricity is actually the distribution transformer. So if you need more power exclusively for your company, you request for a distribution transformer from the utility company. You give the specifications on what apparent power will be needed and what will be the voltage that will be required in your company. That's distribution transformer. So for distribution transformers, these are the apparent power ratings. It is from 3 kVA, the highest is 333 kVA. So at least when you're outside and you try to look at top of the post and you got a cylindrical container over there, those one are actually distribution transformers. Otherwise, it could be a capacitor, maybe the one for power factor correction. But the configuration of power factor correction is actually the capacitor. I think the configuration is rectangular, so actually you could distinguish a distribution from a capacitor. Okay. So if it's rectangular and it's top of the post, it should be a capacitor, the one used for power factor correction. But if it's what you call the cylindrical, and you can see on the sides there are some cooling tubes or cooling pins, okay, welded on it, just like this. to dissipate the heat inside. I hope you have seen this one already. The cooling tubes on the side. Okay, those are distribution transformers power rating. For the voltage rating, there are lots of voltages actually. For a transformer to be considered a power transformer, I still on the camera, the voltage ratings are these. They are high voltages. The lowest one is 2,300 and the highest one is 154,000 volts. So this is actually a very dangerous thing, you know, 154,000, okay? If you got electrocuted maybe in a millisecond, you're burned, okay? So for power transformers, these are the voltage ratings: 2,300, 4,000, 6,600, 11,000, 13,200, 22,000, 33,000, 44,000, 66,000, 110,000, 132,000, and the highest is actually 154,000. Okay? These are the voltage ratings for a transformer to be considered a power transformer. And for distribution voltages, they should be on the secondary side going to the loads already, so the voltages are lower, you know. The lowest one is 440, 550, 2,300, 4,000, 4,600, 6,600, 11,000, 13,200, 22,000, 33,000, 44,000, and the highest is 66,000. These are located on the distribution areas, you know. And the configuration or an example of a distribution transformer that is hung on a post is this one. Okay, so this should be the post. The distribution transformer is of course cylindrical. They got some cooling tubes on the side to dissipate the heat inside. Okay, so at least you now know what's the use of these cooling tubes. I discussed this one under lesson number 2. That is to dissipate the heat inside the transformer. Because the transformer are having a high apparent power and high voltages, so the temperature inside is actually very hot, you know. So for the transformer to have a longer life, we must have to dissipate the heat. Discuss the cooling method of transformers, oil immerse. We got some cooling tubes welded on the casing of the transformer. We make the casing of the transformer corrugated to increase the surface area. That was discussed from the lesson the last time around. So a figure for a distribution transformer is this one. The one hanging on the post. And actually, at around 30 feet, you could visually see the power rating 15 kVA, even the voltage rating for 440 MV. For a power transformer, you could not see it on the post because power transformers are actually rectangular things. They are very big. Okay? So, you could only see this one maybe on substations. After a transmission line, okay, the primary of the what they call the substation is coming from the transmission line. So this is in the range 154,000 volts. 154,000. Right? Then it goes to the secondary side. It will step down to a certain voltage maybe. It will step down to a value of 66,000 maybe. The input coming from the transmission line may be 154,000, but after passing to the transformer and converting that voltage, it will step down to maybe around 66,000 or 110,000. Okay. So actually, power transformers are actually step down. Step down. It will step down the high voltage coming from the transmission lines to a lower voltage. So this could be distributed in the primary lines and secondary lines. And on the secondary lines, Oh, that will be the work of the distribution transformer now. Right? Coming from the power plant transmission line, it will pass to the substation through a power transformer. The voltage will be stepped down here. The step down voltage will be fed to the primary line, okay, and it will be fed again to the so-called distribution line, or distribution transformer. So this distribution transformer, supposing the voltage of this is coming from the primary is an example of this, supposing 13,200, okay, the input of this, so the primary. So for us to use the power rating of this, distribution should step down the 13,200 to a value of around 120. Okay, and this 120 is the one going to our houses. Okay, so it is something like this. The high voltage from the power plant will be stepped down by the power transformer through the substations, and the step down voltage is again paid to the secondary lines, and the distribution transformer will again step down this 13,200. It depends on what is the arrival voltage to the distribution transformer. But lastly, the output of the distribution transformer should be around 120 volts. Okay. Okay, that's it, guys. The next time around, I will discuss the apparent power rating of the primary and secondary. This is where we manipulate, or what you call this, change the value of the voltage and current for these two things to be equal. The product of voltage and current on the primary should be equal to the product of voltage and current on the secondary. This is actually the design equation. Because actually, if we make the voltage high, okay, and the current high, the product of two high values will still be a high value, right? But on the secondary side, if the voltage will be low, okay, the current should be high. Okay? If the voltage is low, the current should be high. So if we try to multiply, this will still be high to accommodate the high on the secondary primary side. Okay, that's it, guys. At least we now know how to classify a transformer according to power rating and according to voltage rating. For the power rating, 500 kV and up is to be considered power transformer, and for the distribution, it will be with the value from 3 up to 333 kVA. For the voltages, these are the voltages for the power transformer. It's from 2300, the highest one is 154,000. And for distribution, okay, it could be from 440, the highest one will be 66,000. And the figure for a distribution transformer will be this, the one that is hung on the post. I hope you have seen this one already. And for power transformers, not unless you have gone to what you call this, at the end of a transmission line, you can see a power transformer there. But if you haven't gone there, I don't think you have seen a power transformer already. But the location of the power transformer is actually at the end of the transmission line that is being paid by the power plant, okay? Because the use of the power transformer is actually to step down the high voltage coming from the power plant to a usable voltage going to the distribution area. Okay, that's it, guys. This is Professor David J. De Los Reyes. Good morning from Los Angeles.